Yeah, good morning, students. So today's classroom topic is pipelining, and what are the disadvantages about this pipelining or drawbacks with the pipelining. So we are going to discuss that particular topic. So now I would like to share my screen. So today's classroom discussion topic is pipeline organization and issues in pipelining. So the lecture objectives are this session will develop the knowledge on understanding the importance of pipelining and what are the major issues related to this pipelining that we are going to discuss. So as we all familiar with that, the instruction execution follows five stage architecture, and we have this in the first stage of the pipelining. So the program counter is used to fetch a new instruction. So that is what we have seen, instruction fetch cycle. As other instructions are fetched, the execution proceeds through successive stages. So at any given time, each stage of the pipeline is processing a different instruction. So here, this is a five-stage pipeline organization. So we already discussed about the five stages in the instruction execution cycle: fetch, decode, compute, and then memory access, and the last stage is that write operation. So here between one stage to another stage, we are making use of some buffers. We are using that. So instruction fetch phase and instruction decode phase. In between, we are using a interstage buffer. B1 we are using here. So which is used for storing the temporary instructions or temporary values. We are making use of certain registers. Those register values are used in the stored in the buffer. So like that instruction decode and compute phase, in between we are making use of another interstage buffer B2. Similarly, between this compute and memory access, interstage buffer B3 we are using, and memory access and write operation we are using interstage buffer B4. Fine. So these are the interstage buffers B1, B2, B3, B4, which are used in between these five stages of instruction execution. So information such as what we are calling it as the register addresses, immediate data, and the operations to be performed must be carried out through the pipeline as each instruction proceeds from one stage to the next stage. So as the information is passing from one stage to the next stage, to hold that information, we are making use of this interstage buffers. So these interstage buffers are the registers which are nothing but we have seen in the data path, this RA, RB, which are used for storing of this address A, address B, like that RM, RY, RZ. These are the registers we have used, and the instruction register IR and the PC temp register. Okay, so to store the values of these registers, we are making use of interstage buffers. We are using that. So the interstage buffer B1, what is the purpose of this interstage buffer B1 here is that it will feeds the decode stage with a newly fetched instruction. So this is a buffer which we have used between fetch and decode phase. And another interstage buffer B2, which is used in between the decode and compute stage, we have used that. So this compute stage requires two operands which are read from the register files. The source and destination register identifiers are immediate values derived from the instruction, and the incremented PC value, which is used as the return address for a subroutine call. So that the control signals which determines the instruction decoder. So the settings for control signals moves through the pipeline to determine what is the ALU operation to be done. So the memory operations which are required, and possibly a write operation to store the result in the register file. So all these are the things which are used to be stored by making use of this interstage buffer B2. Similarly, interstage buffer B3, which will hold the result of ALU operation and which may be a data to be written into the register file, or it may be the data which we have to write into a memory address. So in case of a write access to memory, buffer B3 will hold the data to be written, and these data were read from the register file in the decode stage. So the buffer also holds the incremented PC value which is passed from the previous stage in case it is needed as a return address for a subroutine call instruction. And coming to the interstage buffer B4, which feeds the write stage with a value to be returned to the register file. So this value may be the ALU result from the compute stage, so the result of the memory access stage, or the incremented PC value that is used as a return address for a subroutine call. So these are the interstage buffers, four interstage buffers that are used in between the five phases. Right. So now this is the reflection point one. So the what is meant by pipeline execution of an instruction? Any students, can you answer that? So this already we had a discussion on self-learning topic, basic concepts of pipeline. So pipeline execution is nothing but interleaved execution of the instructions, multiple instructions. So when we are executing the instructions in a pipelined manner, you see that here we have already seen these three instructions are ij plus 1, ij plus 2. These are the three instructions which we want to execute in a pipelined manner. So when we are executing these three instructions in a pipelined manner, so because every instruction requires how many clock cycles for complete its execution? Anyone? So every instruction needs how many clock cycles to complete its execution? So it requires 5 clock cycles. So if we are independently executing these three instructions independently, so 3 into 5, 15 clock cycles are required. But when we are making use of the pipeline concept, these three instructions are executed in an interleaved manner. So if you are executing in an interleaved manner like this, so in the second clock cycle, instruction ij is in decoding phase. During that, the ij plus 1 instruction is fetched. So like this, during clock cycle 3, ij will be in compute stage, when ij plus 1 is in decode stage. During that, ij plus 2 instruction is fetched from the memory. So like this, if you are thinking in an ideal manner that every instruction is executing uh, parallelly from one stage to the other stage during the consecutive clock cycles, then to complete the pipeline execution of these three instructions, we require 7 clock cycles instead of 15 clock cycles. So almost 50 to 60% of the CPU time is reduced here, so that performance can be improved. So it is an ideal overlapping of the three successive instructions. So, but there are many situations it is not possible to have a new instruction enter into the pipeline in every clock cycle. So that is what there are some situations where it is not possible to enter these instructions in a pipelined way during every clock cycle. So if you see that during clock cycle 2, instruction ij plus 1 is entering into the pipeline. During clock cycle 3, ij plus 2 is entering into the pipeline because it is in fetch stage. So during clock cycle 4, if you take ij plus 3, the next consecutive instruction, so ij plus 3 has to enter into the what we are calling it as the fetch phase. So it is not possible, this situation is not always possible, so that every instruction, new instruction will enter into the pipeline during every clock cycle. So if you see that, so the consider the case of two instructions ij and ij plus 1, where the destination register for the instruction ij is a source register for instruction ij plus 1. So that means the result of instruction ij is not written into the register file until clock cycle 5. But it is needed earlier in clock cycle 3 when the source operand is read from the instruction ij plus 1. So that is very simple case here. The ij and ij plus 1. So the destination register for ij is the source register for ij plus 1 instruction. That is the nothing but the output of the ij instruction becomes as an input for ij plus 1 instruction. Then what will happen here? Until clock cycle 5 is completed, the output of ij instruction is not available. So what will happen here is that ij plus 1 instruction is going to read the old value, so that it will not perform the correct computation. Ij plus 1 instruction would be performing the incorrect arithmetic operation because of using of the old value. So what will happen here is that to obtain the correct value, it is necessary to wait this instruction ij plus 1 instruction until the new value is written into the register by ij instruction. So that means now the instruction ij plus 1 cannot read its operand until clock cycle 6. So which means it must be stalled in the decode stage for 3 clock cycles. Okay, so stall means it has to wait until the ij instruction ij plus 1 instruction is stalled, until the instruction ij plus 2 and all subsequent instructions are similarly delayed. Okay, after this ij plus 1 instruction, whatever the instructions that are there, ij plus 2 and all subsequent instructions are similarly delayed. So new instruction cannot enter into the pipeline and the total execution time is ultimately increased. So that is the issue that may arise when we are pipelining that. Any condition that causes the pipeline to stall is called it as a hazard. So what type of hazard it is now in this scenario? So this is called it as a data hazard. So we have identified in this particular example. Fine. So we have different types of hazards also we have. So that we will see in the coming sessions. So this is what the major issue, because we are not thinking of an ideal situation that in every clock cycle one instruction will be entering into the pipeline. Okay, so there may be a situations that one instruction output may becomes it as an input to the next instruction. In that particular case, the subsequent instructions has to wait until the output of that previous instruction has to be available or written into the cpu registers. Fine. So this is what we are identifying the issue in the pipelining concept. Fine. So the lecture level practice problem is that. So what is the role of interstage buffers in pipeline organization? Fine. So after completion of this today's session, so the lecture outcomes are as follows here. So you will be able to analyze what are the advantages and disadvantages or issues in pipelining. Fine. So any doubt? So if you don't have any doubts, now I will stop this session. So thank you one and all.